Okay, so let's look at an example. So what we would like to do is we would like to test these hypotheses using this sample uh, and at this level of significance. Okay, so just by looking at the hypotheses, you should be able to tell that this is a two-tailed test. And I know that by looking at the inequality sign in the alternative hypothesis, right? So we're gonna go ahead and skip step one because the hypotheses have been given to us. So let's go ahead and look at step two and calculate the test statistic. Okay. So in this problem, we're going to be using the t-test statistic. And the reason we're using the t-test statistic is because nowhere in the problem do we see the population standard deviation mentioned, but we have the sample standard deviation, right? So that's how we know that we're going to be using the t-test statistic. And this is going to be equal to x bar minus mu sub 0 divided by sx over the square root of n, right? So we know that x bar is 425. That's given to us. Mu sub 0 is a hypothesized value, which is the value that shows up in your hypotheses. So mu sub 0 is 420 divided by the sample standard deviation of 9 over the square root of the sample size, which is the square root of 8. Okay, so if you put this into your calculator, you should get a test statistic of 1.571. Now let's look at how we formulate the decision rule. For this type of problem, we're just going to be looking at how to do it using the critical value approach. And the reason for that is because it's very difficult for us to come up with the p-value for this type of problem. Okay, so using the critical value approach, remember that this is a two-tailed test, and so our decision rule is to reject the null hypothesis if the test statistic is less than the negative critical value, or if the test statistic is greater than the positive critical value. So our job now is to find the values of the critical values. This is a two-tailed test again, so we're going to have two critical values. Now, previously, if we know the population standard deviation, the critical values are going to be plus minus z sub alpha over 2. Okay? But here we do not know the population standard deviation, and so again we have to use the t table with n minus 1 degrees of freedom. So this becomes t with n minus 1 degrees of freedom of alpha over 2. Okay, so this is plus minus t sub 0.1 divided by 2 with 8 minus 1 degrees of freedom, which is going to be plus minus t sub 0.05 with 7 degrees of freedom. So the idea is we want to go to the t table, look for the t's value that gives us an area to the right of it of 0.05 when the degrees of freedom is 7. So let's go to our t-table right here. We're going to be looking at this particular row because we are interested in the in 7 degrees of freedom. And remember that when you look at the t-table, the very first row gives you the right tail area, right? So here we're interested in a right tail area of 0.05. So we're going to be looking at this column. And so if you look in the interior of the table, you're going to get 1.895 as the t value of interest. And so our two critical values are going to be plus minus 1.895. Okay. So now, if this is our negative critical value of negative 1.895, and this is our positive critical value of 1.895, we're going to be if we are between these two values, then we do not reject the null hypothesis, right? And if we are outside of those two values, right? So if we're here, then we want to reject the null. And if we're over here, we also want to reject the null. Okay. Our test statistic again is 1.571. That we calculated in step 2. So our test statistic is going to be here somewhere, which is going to be between these two critical values. And so our conclusion is that we do not reject the null at 10% level of significance. Okay, and the reason is because negative 1.895 is less than our test statistic, which is less than 1.895. Okay, so in this video we looked at how we do a two-tailed test when we do not know the population standard deviation.